Hey guys, welcome to Leetcode, and today we'll be solving our first question, which is merge sorted array. Now we are given two integer arrays, nums1 and nums2. They are of sizes m and n respectively. They are already sorted in an ascending order. What we're supposed to do is we're supposed to merge nums1 and nums2 in a single sorted array in an ascending order. Now if you read the question properly, you'll find out that this is a void return type function, which means we are not supposed to return anything. How we are supposed to do it is you're supposed to include all the numbers of nums1 and all the numbers of nums2 and put all of them into nums1 in an ascending order. I'll explain with an example. Let's say nums1 has 1, 2 and 3 elements and nums2 has 2, 5 and 6. Then nums1 will already have space built into it for all the numbers of nums2. So it will have 1, 2, 3 and then 0, 0 and 0. So nums1 will be of the size m plus n and nums2 will actually be of the size n. Moving on to our brute force approach, what we'll do is we'll take all the elements of nums1 and all the elements of nums2, we'll just put all of them in nums1 and we'll just sort it. So what we'll do is we'll make a for loop in the start. We'll say for I equal to 0 to I equal to n minus 1 nums m plus I nums1 m plus I equal to nums 2 I. What this will do is, let's say we have nums1 as 1, 2, 3, 0, 0, 0 and nums2 as 2, 5 and 6. So what this will do is this will put 2 here, 5 here and 6 here. Now we'll have 1, 2, 3, 2, 5, 6 and then we'll just say sort nums1 and our question will be solved. But the time complexity for this will be m plus n log m plus n, which is n log n, because it is dominated by the sorting time complexity, which you may know as n log n. But since the size of the total array is m plus n, the time complexity will be this. And this can easily be further optimized, and now I'll move on to the optimized solution. What I'll recommend is that you spend a bit of time trying to think about what can be the actual solution for this. And if you've tried it once, then we'll move on to the optimized solution. We can solve this using 2 pointers. I'll make the arrays again. Nums1 currently is 1, 2, 3, 0, 0, 0 and nums2 is 2, 5 and 6. We'll declare 3 pointers. We'll declare the first pointer at the distance m, we'll just call it p. We'll declare the second one p1 at the end of nums1. What I'll recommend is that you spend a bit of time trying to think about what can be the actual, and we'll place the third pointer at the end of nums2 called p2. Okay, so we're not supposed to put p1 here. We'll make this as p1 and we'll keep this as p. Now what we're supposed to do is we're supposed to compare p1 and p2, and whichever one is greater, we'll place it at p. Let's do a dry run. Comparing p1 and p2, p2 is greater, which is 6. So we'll move 6 to this place. We'll move p one step back and we'll move p2 also one step back. Move this, remove this. And now comparing p1 and p2, 5 is greater. So 5 will go here, p will move one step back and p2 will also move one step back. Now comparing p1 and p2, 3 is greater than 2, so p1 is greater than p2. This will become 3. We'll move p1 one step back and Now comparing it, 2 equal to 2, so we can move any of them here. So 2 will come here, the next 2 will come here, and the next one will come here. At the end, this array will become 1, 2, 2, 3, 5, 6, which is our solution. And we'll place the third pointer at the end of nums2 called p2. Okay, so we are not supposed to put p1 here. I'll show you guys the pseudocode now. So we'll declare one variable p1 at m minus 1, we'll declare p2 at n minus 1, and we'll declare p at the end, which is m plus n minus 1. Now we'll say that while p1 is greater than equal to 0 and p2 is greater than equal to 0, do the following. If nums1 p1 is greater than nums2 p2, nums1 p equal to nums1 p1. So if nums1 is greater, then put it at the end. Else, if it's not, then nums1 p equal to nums2 p2. Always remember to move p2 one step back, and also don't forget to move p1 one step back. Now any of this can work out, but at the end we'll do p minus minus, so we also make sure to move p back. If at the end p2 is left, we'll say while p2 is greater than equal to 0, nums1 p equal to nums2 p2. Same condition. We'll do p2 minus minus, we'll do p minus minus. Why we don't have to do this for p1 is that we have nums1 already in place. So if only the elements of nums1 are left, then we don't really have to worry about anything. We can just leave them there. This will lead to the time complexity O of m plus n and a space complexity of O of 1, and this will be our optimized solution. I'll show you guys the pseudocode now. So we'll declare one variable p1 at m minus 1, we'll declare p2 at n minus 1, and we'll declare p at the end, which is, now our code will be very similar to our pseudocode. We're given the void type return function, we're given nums1, we're given its size, nums2 its size. Again, I'll show you here with the two arrays. Let's say this array has 1, 2, 0, 0, and this one will just have 3 and 4. What you'll do is you'll place p1 at the end here, you'll place p2 at the end of nums2 here, and you'll place p at m plus n minus 1, which will be here. Now while p1 and p2 don't come till this location, which is minus 1, we can keep doing the comparisons. If nums1 p1 is greater than nums2 p2, then we'll move that the greater number here, which is 4. So we'll move 4 at the end, and we'll move this one step back, and we'll move p also one step back. We'll keep doing this while, and if at the end p2 is left, p2 isn't here, so some elements are still left in p2, we'll cover those elements the same way like we do here. And as I already told you, this will end in a time complexity of O of m plus n and a space complexity of O of 1. So that is our solution. If you have any feedback or any doubts, don't forget to drop it in the comments. I would really appreciate some feedback, and thanks for watching.